Hello and welcome back to the second part of this video on grad, which is gradient of a function. So in the previous part, we've looked at introduction of what grad is, the formula, and then we looked at one example. So in this second part now, we are going to be looking at how to solve this example. So it says if a is equals to x squared zi plus xyj plus y squared zk, and b is this, so this is for b. So it said determine an expression for grad a dot b. Okay, so let's do this. So by the way, if you missed the first part of this video, kindly check the playlist on engineering analysis. You'll find the video there. All right, so if you look at this question, just know that this I, J, and K, so pay attention, this I, J, and K are the coordinates of for A and B respectively. Also, if you look at the question, we are asked to determine an expression for grad A dot B. Now it's more like a two-in-one kind of question. Since we are having A dot B, that A dot B is what we call the dot product. Exactly, we have the dot product and the cross product. Since A and B is a dot product, so what we are going to do is we are going to multiply A and B using dot products. Exactly, take note of that, using dot product and not cross product. All right, so what we are going to do is let's write out A. So we are having A to be, so that's having A is equals to x squared zi plus xyj plus y squared zk. Okay, and we are having b, our b is equals to yz square I plus xzj plus s squared zk. All right, so one thing you notice with what I'm writing for proper understanding is that I'm giving enough space between the I, J, and K. Exactly. So if you are to apply the dot product here, which is A dot B, so what it simply means is we are going to multiply this together, this and this. Exactly, because we are both having on the same coordinates I, J, J, and K, K. Are we good? All right, so let's start with the first one. If you should multiply this together, we are going to be having x squared yz cube. So take a look at it very well. We're going to be having x squared yz cube. So if you also multiply this plus, so there's also something I also need to mention here. So since it's a dot product, once we are multiplying this together, so once we are multiplying, hold on, once we are multiplying this together, the coordinates won't be there again. So take note of that. So now the next one, let's multiply this together. We're going to be having x squared yz plus, so if you should multiply this, it's going to give us x squared y squared and then z squared. Are we good? So having done this, now we've been able to get the value of our a dot b. So now we can go ahead and calculate for the grad. Okay, sorry, it should be in the opposite way. The grad of a dot b. All right, so this will be partial differential of a dot b over partial differential with respect to x plus partial differential of a dot b with respect to y. So don't forget it, ij plus partial differential of a dot b with respect to z along the k coordinates. All right, so now let's start with so what will this give us now? So what we want to do is, what we are having here is what we are going to be differentiating. So let's start differentiating it. Let's look for the partial differentiation with respect to x. So in different, starting with this, so that will give us 2x, because if you differentiate x squared, that will give us 2x. So the remaining one, which is the y and the z cube, is this z cube? Yes, and the z cube, it will be a constant. So that will give us 2x y z cube. So let's go to the next one, plus. So if you should differentiate 2x also, it will give us, if you differentiate x squared, that will give us 2x. Then this yz will be a constant. So that will be 2x yz plus the same thing. If you differentiate x squared, that will give us 2x. Then this y squared and z squared will be a constant. So that's just the concept of partial differentiation. So that will be 2x y squared z squared. Exactly. All right, so something is common with all of this. So if you look at it closely, you see that 2xyz is common all through. So we can decide to just bring it out. So we are going to be having 2xyz or z, that will be z squared plus 1 plus 2xyz. So that will be left with y and z. Exactly. All right, so that sorts out for the first one, which is this. So let's do the second one, which is, so the partial differential of the cross product of a and b with respect to partial differential of y. Okay, all right. So if you are to do for y, so now if you should differentiate y is 1, so that means our x squared and our z cube will be a constant. So we'll be left with x squared z cube plus. So let's go to the next one. If you should differentiate y, it will be 1. So x squared and z will be a constant. So we'll be left with x squared z plus. So if you should differentiate y squared, that will give us 2y. Then x squared and z squared will be a constant. So that will give us 2y. Okay, sorry, let me arrange this properly. That will be 2x squared z squared. So this also, if you look at it closely, you will see that x squared z is common. So you can just write that out. You can factor it out rather. So that will be 2s squared z. So what will be left with will just be z squared plus 1 plus it's just s squared z that is common. All right, so let's continue. Okay, so that will be plus 2. Let me correct this. So plus 2. All right, so we omitted y here. Sorry. So if you should differentiate, like I said, if you differentiate y squared, that will be 2y. All right, so this will be 2yz. Okay. All right. So now let's do for the last one now. So that will be partial differential of the dot product of a and b with the partial differential of z. Okay. So let's look at that of z. Okay. So if you differentiate z cubed, that will be 3z squared. So x squared and y will remain as a constant. So we'll be having 3x squared y z squared plus. So let's go to the next one. So if you should differentiate this, if you do that of z, z will be 1. So x squared and y will remain as a constant. So we'll be left with just x squared and y. So let's write this. So x squared y plus. So if you should differentiate this, if you should differentiate z squared, that will be 2z. Then the x squared and the y squared remain as a constant. So we're going to be having 2x squared y squared z. All right, so let's write that. Plus 2x squared y squared z. All right, so also if you look at this closely, you see that x squared y is a common factor with all of them, so you can just factor it out. So that will be x squared y, then into brackets. So for this we'll be having 3z squared plus 1 plus 2yz. All right, so we are almost done. So that means our grad of the dot product of a and b will be given as, so let's go to the first one. So this, so let's write it out. So that's 2xyz, then into bracket z squared plus 1 plus yz, z squared plus 1 plus yz. So then put everything in brackets. Don't forget the coordinate I plus, okay, so now this, which is s squared z, then bracket z squared plus 1 plus 2yz g, then plus s squared y, which is this. Now 3z squared plus 1 plus 2yz. Okay, so finally we already have our answer, which is what we are having here. So this will be the answer to the question exactly. So that is it on this example 2. I hope you find value in it. If you still have any question or any doubt, do leave them in the comment section, and I'll definitely attend to it. So if you are yet to still subscribe, please take out time, click on that subscribe button to subscribe to the channel. So the lecture on grad dive and calls continues in the next video. Thank you.